Guys, we're looking at stuff on the discriminant now. So I gave you the quadratic formula here. This is going to be page 570, looks like 574 homework, but I just want to kind of introduce the discriminant again. The discriminant is the part of the quadratic formula that tells us how many solutions the thing's going to have. Again, the number of solutions is the same as the number of x-intercepts it has. So the solutions for a quadratic equation are the same as the number of x-intercepts or the real roots. All these things are the same, mean the same thing. So we look here. The discriminant is this part right here. I'm going to get a different colored pen. This is the discriminant. Whatever's inside that square root. It doesn't include the square root part. This is the discriminant. What it allows us to do is discriminant. It allows us to discriminate how many solutions a quadratic formula is going to have, or a quadratic equation, I should say, is going to have. All we have to do is find the value of this part, of b squared minus 4ac. If b squared minus 4ac is negative, remember, if whatever's inside the square root is negative, we're not going to have any real solutions, so no real roots, because we can't have a square root of a negative number. If it's positive, we're going to have two real roots, because if this is positive, it's just going to be a number, so we're going to have plus or minus some number. That has to give us two different solutions, right? No matter what this is, if it's a positive number, it's going to be something plus that number and something minus that number. That will give you two different solutions. So you'll have two real roots, also known as two solutions. And then if this part equals 0, so if it equals 0, then plus or minus 0 is only going to equal the same thing. So plus or minus 0 means you're not going to have two different solutions, even though there's a plus and minus. So we're only going to have one real root. What that means when we graph it, if we graph something, a quadratic equation with no real roots, it would look like this or like this. It would never cross the x-axis because it has no real roots, meaning it never has any intercept with the x line. If it's positive, it's going to have two real roots, so that's going to look either like this or like this. It's going to cross x twice. And if it has one real root, which is kind of a special situation, it's going to just touch x right there, or it could touch it here like that. It's just going to brush the x line. It's going to be tangent to it. It won't touch it twice. So that's the idea behind the discriminant. Now I'm going to go over a couple problems. I'm going to do, I think, 1, 9, and 1, 5, 9, 13. So I'm going to do 1, 9, and 17. So number 1 on page 574 looks like x squared minus 5x x squared minus 5x plus 4 equals 0. So all we need to do to find the discriminant is to find a, b, and c like we always do. So a is 1, b is negative 5, c is 4. We just have to do b squared minus 4ac and see if that's positive, negative, or 0. So I'm going to plug in negative 5 for b minus 4 times 1 times 4 there. So I get 25 minus 16. That equals 9. Is 9 a positive number? It sure is. So we're going to have two real roots for this quadratic equation, which means when we graph it, I don't know exactly how it's going to look, but I know it's going to have to cross x in two separate places. And we can solve it to figure out exactly where it crosses x, but I just totally made this up. I just know that it crosses in two places. I don't know exactly where it crosses. Let's look at number 9. So number 9 is going to be negative 5b squared plus b plus 1 equals 0. So again, here they want us to know the discriminant, so that's going to be b squared minus 4ac. I know a, b, and c we need to find. So a is negative 5, b is 1, because it's the coefficient here. Even though they're b's here, think of these as the x's. just because they use b. So this b and this b are different, but b is 1 because that's the coefficient of this term right here, and c is 1 also because of that one. So I'm going to sub it in. So b squared, I get 1 squared minus 4 times negative 5 times 1. So I get 1, and negative 4 times negative 5 is positive 20. So and 20 times 1 is 20. So I get 21. So is that a positive number? Absolutely. So I know this equation is going to have 2 real roots also, because that number is positive. Let's try number 17. Or no, I'm sorry, 9, 13, 17. Yeah, let's try number 17. That's a B problem. Shouldn't be any problem. Page 574. Number 17 is going to be y equals 7x plus 2 minus 3x squared. Okay, they're trying to nail you here just by changing the order. If we always turn stuff into standard form, we're going to be in really good shape. So I'm going to do y equals, and I'm going to switch this around into standard form, negative 3x squared plus 7x plus 2. If I didn't do that, I never would have been able to get the answer. I would have mixed up my a, b, and c. Now I know my a is negative 3, my b is 7, and my c is 2. Now I can just plug these into my discriminant, which is again b squared minus 4ac, and see if our number is positive, negative, or 0. So if I plug in 7 for b, I get 7 minus 4 times negative 3 times 2. So 7 squared is 49. I can do this a lot of different ways, but negative 4 times negative 3 is positive 12, times 2 is positive 24. So this equals positive 24. This equals 73. Is that a positive number? Yep. So again, we're going to have 2 real roots. So for number 17, we're going to have 2 real roots, just as we did for number 1 and number 9. So you would do 1, 5, 9, 13, and 17 for this homework. So we did 1, 9, and 17, and all of them had 2 real roots, means the discriminant was a positive number.